Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today we are going to look at a very interesting LeetCode problem, LeetCode 73, set matrix 0 in place. This question is a difficult one in the sense that you have to replace everything in place rather than doing it in a copy of the matrix, and hence where the complexity comes in. This question has been an all-time favorite for several companies such as Amazon, Microsoft and Google. Let's look at what does this question say. So you have been given an m by n integer matrix as shown here. If an element is 0 in either of the row or columns, set its entire row and column to zeros, and you must do it in place. That's a complexity. Now let's look at some examples. So the example 1 shown here, you have 0 in first row and first column here. Hence you set the entire first index row and first indexed column as 0. Similarly, in example 2, you have been given a 3 by 4 matrix where you have zeros in first row in the 0th column and the 3rd column, as you can see here. And hence, in your result, you have set the entire first row as 0 because it has zeros. And you have also set the 0th column and the 3rd column as 0, all the elements, because it had 0 in the first row. You can see here, right? And you have been given a possibility that there is a solution possible to do it in O of m into n space complexity, and then there is another solution possible to do it with O of m plus n space complexity, but the question asks, can you do it with constant space solution? So I will be depicting both solutions here, the bad one and the good one, starting with O of mn space complexity and going to O of m plus n space complexity and further to O of 1 space complexity. If you have any questions, solve this question alongside me and ask your doubts in the comments here. I'll be happy to delve deeper into them. So let's look at the first approach. So the first approach with O of m into n space complexity would be that we take a copy of our input matrix here, and instead of replacing all the elements in place, we do that in a copy. And why is it so? Why cannot we do it in place? So say suppose you have a 0 here, right? And you start from the topmost row and the leftmost column, and you go from top to bottom and left to right in the matrix, and you come across each element and see if it is 0, then you set that particular row as zeros and that particular column as zeros. In that case, there is only one drawback. Say suppose you come across this 0, this cell that is the first row and first column, and you set everything in first row and first column as zeros in place. So you would replace this 1 with 0, you replace this 1 with 0, this 1 with 0 and this 1 with 0. And when you come across row 1 and column 2, in that case it would have been set to 0 already because you had set the seed to 0 earlier, but you don't know that you had set it. And what you would do, you come across the 0 here and you would set this particular row to 0 and its column to 0. So that would lead to false results. And hence you cannot do this in place in this manner, and you are using a copy of the matrix here where you go through the input cell by cell and see if it is 0, then you set that particular row and column as 0 in the copy. And that's what I have done here. So I hope the approach is clear. So since we are using additional matrix to do that, hence the space complexity is O of n, O of m into n. The time complexity would be much greater than O of m into n. That's because you would first use O of mn time to go through the entire matrix of m cross n specifications. Secondly, you would go through the matrix of the copy to update those rows wherever you tackled a 0, and then you will go through the matrix to update those columns where you tackled the 0, and you would do that more number of times, hence the space complexity would be greater than O of mn. I hope you understand this. Now let's look at the second approach. Now you must be wondering, do I really need a copy of the entire matrix to store which elements turn to 0 and which elements do not turn to 0, or I can find a solution which is less complex in terms of space complexity and still makes us replace the elements in place. So for that, this is the second approach, which is O of m plus n space complexity, where I'm not using a duplicate or a copy of the entire matrix, but I'm using two arrays, one for tracking the row and the other for tracking the column. So here what I do is I go cell by cell like I was going in the prior approach, starting from the top left corner and going top to bottom and left to right, and I go through each cell. So as soon as I come across a 0 in a particular cell, then I mark the row corresponding to it in this array as a cross or as a 0, so that I know which row I have to update at a later stage. So I don't update it now, but I mark it that it needs to be updated with zeros, since there was a 0 in that row encountered when I was going through the array. Same ways, I will mark this particular cell here in my array as or 0, where I will be taking this into account to update the entire column for zeros later on once I have navigated through the entire matrix. And I'll go through each cell and keep on updating that ways. So I will use O of mn space complexity to just loop around the entire matrix and mark these cells. Then I'll use another O of mn time to update the rows wherever I have encountered zeros. And I'll use another O of mn to update the column wherever I have encountered zeros earlier. So my time complexity would be O of mn into 3, since I'm looping through the entire matrix 3 times. And my space complexity would be O of m plus n, where m and n are number of distinct rows and columns present in the matrix. Because I'm not using a copy of the matrix as a whole, now I'm using one array to represent the entire columns, number of columns, and one array to represent the number of rows in the matrix. And I keep on updating them as and when I come across a 0 in a particular row or column. And then I update the matrix accordingly. So I hope you understand this approach. Now let's look at the third approach, which is our final approach with constant space complexity. Now for the third solution, if you want to have O of 1 space complexity, that means you cannot use separate arrays to track the rows and column number where you want to turn the elements to 0, since you have encountered 0 while you are looping through the entire matrix. So to do that, can you use your 0th row here of the matrix itself and your 0th column here of the matrix itself to track which rows or columns you need to update at a later stage once you have looped through the entire matrix? So yes, you can do that, but there's only one question here. If you use the entire 0th row to track which columns to update at a later stage, and entire 0th row to track which rows to update at a later stage, there's an overlap, which is cell 00. So what will you track there? You will track the column to update or the row to update. So for that, we have to use a one extra cell to track which row to update here for row 0. But we can use this cell 00 to track 0th column, whether to update it with 0 or not. So that's the only difference, even though you're using one cell to track this value, for whether to update 00 with zeros or not, but it's just one cell, so it's still O of 1 space complexity. And how do we code here? So we basically start from the top left and we go from top to bottom and left to right, and we navigate through each cell. Wherever we encounter a 0, say for example here we encounter a 0 in first row and first column, then we do not set everything to 0 at that time. We just set the first 0th row, 0th column and the first row cell this here, cell 01 here as 0. And we also set this particular cell in 0th row and first column as 0 here. And we can update it at a later stage once we have looked through the entire matrix. So basically, in place of using additional 2 ways to track which row and column to update, you will be updating your 0th row and 0th column to show that this is the particular row which need to be zeroed, or this is the particular column which need to be zeroed. And you can do it once you have looked through the entire matrix. And you handle this overlap between 0th row and 0th column by using additional cell, which you can code as row 0. So with that cell, you track whether that 0th row needs to be updated with zeros or not. So I hope this is clear. This reduces your space complexity to O of 1 and your time complexity to O of m into n, because you loop through the entire matrix, so it's bare minimum O of mn. And then you update with the zeros as you have encountered zeros and you have updated directions in 0th row and column. So you update the matrix accordingly. So you loop through the matrix more than once, and hence the time complexity would be O of mn. So I hope you understand the question clearly now. Let's start coding it. Now first of all, this is an O1 space complexity solution, and we first initialize rows and column as the variables because I don't want to call them again and again. So rows would be length of matrix. My columns would be length of matrix 0. That is the length of first row of the matrix. And I also initialize my Boolean variable for tracking the overlapped cell, which would be false initially by default. Now I will determine which rows and which columns need to be 0. So to handle that, I will loop through the entire matrix for R in range rows and for C in range columns. And after that, I will check if matrix RC, that is the particular cell, is 0. If it is 0, then what do you do? In that case, you set matrix 0th row and all the columns as 0, because you have to mark that we need to update this particular column later on or this particular row later on, and hence you are updating. Same ways you will also update all the rows apart from 0th row, because for 0th row we are updating row 0 variable. So we'll update matrix R0 as 0. And we can update our entire matrix with zeros accordingly later on. And if the R is 0 here, then you update your Boolean variable row 0 with true. So by this method, you have marked all your rows and columns in your 0th row and 0th column to update which all rows and columns need to be set to 0, as they have 0 element present in the current cell in that particular row or column. And now you loop through the entire array again to update, okay, accordingly. But you do not loop through the 0th row and 0th column, because there the zeros represent the columns or rows you need to update. They are not actual values from the input matrix. So that's why you loop from first row to all the rows, and same way you would loop from first column to all the columns, because your 0th column and 0th row track your rows and columns to be updated, okay? And to update it, you check if matrix 0C is equal to 0 or matrix R0 is equal to 0. That is, you have indicated to update either that particular column or that particular row. In that case, you update matrix RC to 0. Okay. So now you have updated, but you have not handled that condition when your matrix 0 is 0. In that case, if this particular cell 0 0, that is 0th row and 0th column is 0, in that case you have to update the entire column, because it tracks your column, right? So to update the entire column for R in range rows, you update matrix R0 equal to 0. So you update the entire columns, okay? All columns in that particular row. Now you check your Boolean. If row 0 is true, in that case you have to update the 0th row, right? With all the cells being 0. So for C in range columns, and you update matrix 0C equal to 0. And this is your entire code. You have updated everything accordingly. If you have encountered 0 in that particular cell, in that particular row or column, you have updated those rows and columns to 0. Let's run it. So we got runtime error. This is a spelling mistake here. Let's run again. So it's accepted. Let's submit. So as you can see, our solution is doing well here. Let me refresh and explain you the code again. So first of all, I took two variables, rows and columns, to denote the number of rows and number of columns in my entire matrix given to me. And I also took the overlap cell, that is cell 0, 0, to track whether I have to update that particular row as 0 or not. For that, I took a Boolean variable row 0 and I initialized it with false. That is, I don't have to update it. Unless I encounter any cell as 0 in 0th row, this will not get updated. Then I loop through the entire matrix for R in range rows, for C in range columns, and I check if any of those matrix cell values is 0. If it is 0, then I update my values in that particular column and row accordingly. But if my row turns out to be 0th row, in that case I update my Boolean variable. That's what I'm doing here. Now once I have an indication which row and which column to update, after that I loop through my entire matrix and I keep on updating it. But I'll not loop through the 0th row and 0th column, because those are the rows which are tracking my columns or rows to be updated. So I'll not loop through 0th row and column hence, and I'll start from first row to all the rows and first column to all the columns. And I check if I have encountered a 0 in 0th row and 0th column for those particular rows and column. If yes, I set the cell to 0. Now I handle the edge cases. So if my 0th row, 0th column cell, that is matrix 0, 0 is 0. In that case, I have to update the entire 0th column with zeros. That's what I am doing. So I am updating all rows in the 0th column with 0. Matrix R0 as 0. Now if my boolean row 0 is true, in that case I have to update my entire 0th row with zeros. So hence I am updating all the column and range columns with matrix 0C as 0. This way my entire 0th row will get updated with 0. That's my entire solution. If you have any doubts, ask them in the comments here. I'll be happy to address it. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Also do mention in the comments what question you want me to prioritize or solve first from LeetCode. I'll be happy to solve it the next day. Thank you.